So let's take an example, the customer churn here. What we're trying to solve, how can I prevent customers from leaving? Create a variable, well, churn flag, true or false. Did the customer stop doing business or not? Are there glaring problems? Yes, I mentioned the churn flag. I mean, every customer is going to churn, eventually. I mean, let's say you have a customer, Randy Sherwood, and Randy might, churn eventually. And so, how are you going to define if Randy has churned within the right context or within the right time period that you allow or you define a customer has churned or not? So you might create sliding window and you're trying to check, whether it's a year or 2 year or 3 years for that particular flag. And then the level of insights, well, you want to make sure that the granular level of the data set here is a customer. So every record is a unique customer. Again, make sure that they churned in that particular time that you're checking. And then decide the appropriate scope of the data. Again, how long you're going to go back and get all 2 years worth of data, 1 year, 5 year, 10 year, and then the variables you're going to include, make sure that they are meaningful to the problem you're trying to solve. For example, if you have a customer churn reason, again, if churn reason is populated and you include it in the story or the data set, that's not helpful. And by the way, Einstein Discovery is going to give you data improvements tip, and typically it will find out that churn reason is 100% is a strong indicator, and you should take it out. But still, even before you get to there, let's start getting used to these concepts and these 6 steps that I need to define or box my business use case into them, get those answers before even getting to the data and using Einstein Discovery. Now, I know we mentioned the business use case, and I'm going to say again, let's stop. Before even going to the tool, before even covering the technical aspect, and before going into the typical conversations of how accurate your model is and what are your model metrics and etc. The most successful criteria for your Einstein Discovery project is going to be the business understanding, the business experience, the business understanding of what you're trying to do, how you relate what you're looking at the data at the fields, what are the fields you're trying to bring in, the fields you're trying to derive, create, or feature engineer, if you hear this word, is creating those extra fields that will help your model get better, or at least get you the accurate results, or the most accurate possible results you want through your prediction. And for that, we cannot underestimate certain steps that have been around. For example, this methodology, the CRISP DM methodology, right? That when you approach a typical, I don't want to call it data scientist project, but typically, if you want to approach this particular use case where you want to build a model and predictions on this particular data, you have to go through the business understanding. You have to go understand what the business is trying to ask for. This particular use case, again, trying and funneling all the questions, everything we're trying to do from different asks to that particular business use case that I'm going to try to minimize and maximize to enhance whatever I'm trying to do with my business. The data understanding, so I now, again, like in those 6 steps, that now that I understand what it is, do I understand the data around it? Do I have all the data? Do I need to create some more fields? Do I need to drop any fields, etc.? Data preparation. So to get me there, do I need to use the data prep tool, for example, in Tableau CRM and recipes? What can I do with that? What are the things do I need to join data? I have external data, etc. Modeling. So when you are importing into Einstein Discovery the data, right? You're running various stories, different models. You're going to see that we're going to run these fast, and every time we might run different versions. And that means we are going to determine which version, which story, which particular model we're going to use depending on its metrics, how it's performing. And then evaluation, of course, you're going to evaluate the model. You might have, again, a data scientist member or the data scientist team as a board member or advisory member, checking your model and saying, okay, this looks good, or maybe here's an idea. But it is, again, a big deal that you're going to take this and deploy it in production and have business decisions made on those predictions, etc. So it is something to keep in mind. And even how you're going to deploy it. Are you going to deploy it? Even evaluation. So even between evaluation and deployment, you might consider a dark launch period where it's, for only few super users have access to it. They can see the predictions. Or you might be scoring data behind the scene, and over a period of weeks or month, you are monitoring and seeing, okay, how did my model live, perform to compare the actual versus predicted, etc. And then when you deploy it, you operationalize it. Well, it's not just one time. You need to also keep monitoring it. You can do that through Model Manager, for example, and keep an idea on the accuracy, maybe through accuracy template, etc. So all of these we're going to cover. But as you can see that, again, the model and evaluation are pretty much right here. These two are just two out of, for example, in this particular methodology, out of the 6 steps. So it is a lot to do with the business knowledge. And I'm going to use a few examples again to solidify that idea. So if you think about opportunity scoring, let's say we have a problem, or the problem is simply saying, predict for me if the opportunity is going to close or not. And at the surface of it, you could think and say, all right, give me my opportunities, one data set, all of opportunities. I have a bunch of fields, and I'm trying to just maximize or minimize. Maximize 1 equal true, or 1 equal 1, or minimize 1 equal false, for example. And I will say, okay, well, am I okay with my typical standard opportunity fields? I have stage, I have maybe the product, the account, information, the industry, who's on that deal, the amount, etc. Those are my typical fields, but that might not be enough by itself, because if you think about it, even opportunities, they're not all equal, not just because of their amounts or what we're selling with them or the accounts they're associated with, but it could be even the activity. For example, activities. There are no activities in early opportunities. There's not a lot of information to read or to try to predict. In the early stages, not a lot of activities, not a lot of teams engaged, not a lot of discounts. But when the up qualifies or moves to another, mid to advanced stage, you have way much more information on that opportunity object. And then even the last mile, that last final stage, even at that point in time, we have so much more information to consume. So if we think about it, now we just went from this is one big data set opportunities and we can build the model and we're done with it, to wait, we might actually need 3 models for 3 different stage categories. So opportunities in stage 1 and 2 and 3, maybe use this model that only has 4 input fields, or 6 or 10 or 15. And then opportunities in the mid-range, well, now they have maybe 20 to 30 more fields, then their model is different. And then opportunities in the late stage, and so forth. If you think about it, there's a lot of ways you can slice and dice that information, because we just talked about stage. You might make the same argument about amount, or the same argument about the account type. You might create a a model or a story for amount, for opportunities, not just amounts. If their account is EB, or for example enterprise, we use enterprise level, or if it's a small level, or if it's mid level. So again, the opportunities or the possibilities are a lot, and this is where it's a mix of business knowledge, data knowledge, and a little bit of statistical terms to understand, okay, what do I need to do with this data? Because the business knowledge here, as I started digging into the data, turned out to be, it's not just a simple look at the data and give me the model. And this is where a seasoned let's say a sales cloud expert in this particular case, would understand that, hey, these are different, we should treat them differently and create probably different models for that. I want to go back to the customer churn just to show you that the first time we went through that use case, it was a straightforward conversation, but hold on a second. It may not be just I'm trying to determine that variable churn and when did they churn. If I'm trying to predict a churn for B2B customers, well, at 10K meter level, the problem is, okay, the customers are churning. But if we look at it deeper and say, well, define churn. Is it full churn or they are just canceling some products? Are they buying, they had Sales Cloud last time and now they want Tableau CRM or let's say, they bought something and then, they're not renewing that service, etc. So now I'm thinking that the data, I need to look at it from a different perspective. I need to dig into it a little bit deeper and not just a churn flag that is about a sliding window or when did they churn. It's actually define my churn. Is it a churn of 3 products or more, or is it 2 products or more? And what are we going to try to maximize and minimize in that particular scenario? And how did they churn? Was there an indication because of the usage, or are we actually saying, hey, if they have a product but the usage is going down, so we're going to predict churn for that, or are we waiting till the end and say, okay, they're churned, and then trying to learn from the data? So there's again a lot of ways you can look at this particular scenario, and again, it is all or most of it is in the hands of that business expert, the business scientist, to bring to the table that, hey, we're going to look at the data from this particular perspective. We might create multiple models again for these different scenarios. So again, customer churn, opportunity scoring, not so straightforward as you might think about it, from first time, and we're not even at the stage where we're talking about the model accuracy and what we're trying, how much it's accurate in predicting the values. And again, focusing on the churn just because it's a simple concept, I think, or a simple idea to relate to. If you think about the telco churn and you start with whether you're talking about it from a business entity perspective or a table perspective, even for your cell phone or telephone subscriptions, you want to think about your customers in different categories, right? So you have teenagers, you have a senior citizen, you have a family plan, you might have a business user plan. Okay, that isn't the data. I know that I have that. I know I have my account, and now you're telling me, okay, from a business perspective, I might want to think about it if I have this categorization, this type. And that's a good question, because I don't know if in that table there is that type that says teenager, senior citizen, a business user, or family. That field might not exist, and I need to go and determine that. Why this matters? Because again, from a business, from an SME, they probably think, they look at the subscriptions and they categorize it by these 4. Just as an example. Why? If you go to the next slide, because each one of these categories, their churn might be, due to a reason completely different. So if you think about teenagers, well, they probably churn if they don't have the latest phone. So latest phone becomes a value, whether it's a dimension or a value in a dimension in the data set that I need. I don't know if I have that, but as of now, I'm just drawing the business understanding of the problem. I started with, I'm looking at the churn of my, let's say, mobile phone subscribers. Well, if you ask about from business, how do you go and identify the problem? Where, again, one way here we're trying to look at it is from teenager, senior citizen, family, business user. Within each category, what are the things that might relate to that churn? Is it the latest phone? Teenagers and data plans might not have everybody on the same network. Again, this might be a little bit older but again, applicable just from an understanding perspective. For a senior citizen, complexity of changing the phone, or calling someone, or even replacing the old phone. They get used to the old phone, for example. Family, do I have the last triple play option, so forth. Business users, again, everyone on these particular categories has probably a different reason that can lead to a churn. And if I go one more step down, now I am translating. Notice I'm translating the potential issues or potential indicators of what could relate to this particular category into metrics. So when I say, well, teenagers, what do they care about? Do they have the latest phone? How do I translate that into a dimension in my in my data set? It's probably a time since last mobile replacement, okay? Or it could be a flag, but it's a time since last mobile replacement. And how many calls they do to out or other networks, let's say, or do they have the latest speed options? What about senior citizens? How long they've had this contract? Again, time since last mobile, and so forth. If you go on the other side, now that I've went from the business statement, what is the problem I'm solving? What is the variable I'm trying, to handle? But within the context, what are the things I'm trying to specify? What are the other fields, the other derived fields, or you might hear, feature engineering, fancy word for the same, pretty much. In this particular context, I'm not talking about the model itself and how the data is translated, but in this particular context, these are things I need to put on paper or on slides and go and figure out the derived and create these fields if they're not in my data set. They might not be from the first try, because remember, Einstein Discovery can run the data set quickly and get back some results and then figure out what you want to do. But eventually you want to have this in the data, and you need to figure out, because these fields, when you input them into the story of the model, it will absolutely make the model more accurate and more a little bit, and the model metrics themselves will get accurate. And this is the trick, or this is the skill set. This is the skill set that's going to be very much valuable right now in someone understanding the business, translating the problem into these kind of questions and KPIs, taking these to the data layer, creating them in the data, what these metrics mean, getting them into the story or the model, and getting better models and accurate or more accurate predictions. That's pretty much the business scientist. One aspect, and that's why I said stop. The business knowledge is very important. You need to be able to walk your business users into this kind of, let's say, diagram or scenario, and deduct what do you need for the data prep. So it could be 2 phases, could be 1, could be 3, but typically our recommendation is first time you get the data, just get it, even if it's a CSV extract. Get the quick and dirty way to load it into Einstein Discovery and see what you get. You will get data improvements, you will get some insights, you will start deducing things that you need to do with it. You run it few more times, and then you move to phase 2. Now, why this is important? Because I don't want you to get stuck at, I have data coming from Salesforce, I have data coming from another database on-prem, from another cloud. I need to bring them into, this is Salesforce, let's say those are other clouds. And don't waste time in the beginning on the data prep and the ETL tools. Get some CSV extracts, that's fine. Get them, figure out what you need to do, what things you need to clean or create, because out of the 100 plus or 200 plus or 300 plus feeds, you're not going to be using these for your one particular model, right? You're going to see that it's, in general, they all consolidate to 25, 30 maximum fields per story, right? Per particular use case, per, opportunities in these stages, versus opportunities in other stages, etc. That's phase two. That's when you have figured out the fields that are meaningful for the model, and now you know what they are. Now you can go and implement and start figuring out, okay, what my ETL needs to bring in the data prep, etc., etc. So don't let perfect be enemy of good. That's very important, especially in the beginning when you're just trying to get something. Even later on at the stage where you're ready to deploy and at least test, because the value that you can deploy the model today and get some improvement to the business. Of course, this is again not here. We're talking about towards the end. Get some value to the business is highly likely more valuable than spending another month just tuning the model metrics for another 2% or 5% accuracy, etc. And you can always actually change that, come back and refresh the model. And another thing is, this typically some folks do ask about it. So, like, even if the data is not super clean, as long as the bad data is uniformly distributed, across the different fields. So let's say you have data in EMEA and you have data from AMER. As long as you have some the same percentage or evenly distributed some noisy data, it's fine. And even if not, Einstein discovery in the beginning should flag it out for you. We have cross validations and we have other ways to just give you some of those insights. But again, the main thing here is get the first stage, get the first fields, go through a few iterations, and then go through the final number of fields, identified fields, the right fields you need to deploy. So here are some additional final thoughts here. Again, it's not just capturing the data. It's not just about the model accuracy. It is, what is the problem? Am I looking at it from the right business perspective, to the right even category, to the right derived metrics, and I need to create, or they are there. The data preparation, is it in Salesforce? Is it outside? How are you going to bring it in? How are you going to refresh it? You don't need to refresh the model every day. It's not a dashboard, but you do need to refresh it at some point in time. And oftentimes you will need to add those again additional fields. So you might need to change dates to durations. So like I said, the last time, when did the teenager get the phone versus how long the teenager have had that phone. So that's a duration. That's a more meaningful metric that we can build on. And sometimes you need to pivot the data or derive some flags, right? Maybe the flag is not there and it's based on a condition. This field and that field equal to X, then 1, else is 0, etc. You want to start with phase 1, as we mentioned, at least get some minimal decent model. Then you figure out which fields that got dropped and which fields that stayed, and you want to kind of send it to production or from a data prep perspective, etc. And deployment, again, how are the users going to consume this? In Salesforce object, in a real time, in the lightning card, or is it going to be scored behind the scene? Are you going to provide a dashboard that aggregates these predictions and shows me my top 10 predictions so that I can take an action on them? Or are you going to score this outside Salesforce through API or in Tableau? Again, different ways, but you do need to think about these again at the beginning. So what it does, again, recap, it uncovers insights backed by statistics. A lot of time is not the magic. It's probably confirming what the 10% or 5% of the SMEs in the business know, but it's confirming them mathematically and sharing the result with the rest 90%, 95% of the end users who might not have that business acumen knowledge to take a decision on that particular problem they're facing, a record, or etc. And so again, it does not deliver a continuous, all the time aha or magical moments. A good fit would be maximize, minimize outcomes. It gives you recommendations based on patterns. So if you see patterns in the data, it gives you, we're going to see the why it happened, for example, or some other charts that are helpful that brings these explanations and actions. And it's not a good fit for example, next best action, affinity analysis, anomaly. It's not good at a finding an anomaly versus finding patterns. There are ways you can switch the data, how it is being fed into ED, or you can focus on outliers if you have maybe enough outliers. But again, typically it's not good for the anomaly description. Although again, some folks have figured out different ways to kind of switch the data to highlight anomalies. Textual, nope, we don't do textual, and not a time series. So we do have time series in the product and the dashboard layer, and we have it actually also in the data prep recipe layer. As of now, it's a pilot feature, but it is there. You can apply time series there. ED is not a time series engine, so I cannot predict this stock in 20 days is going to go up or down. It's not the time. It's just like I mentioned before. It's the binary or the amount. And switching to the assets. So these are some of the terms. Well, first the assets. You need to understand from the whole Tableau CRM, where we have data sets and data flows and preps and recipes and lenses and apps. When you talk about Einstein Discovery, you're still dealing with data sets. So you got to bring the data in as data sets, or create it at least, whether it's from Salesforce or external. And then you're probably using data prep for either combining these data sets into one, or at least creating the right fields and durations like I mentioned, or flags, or whatever you're doing with the data. So you're probably using data prep right here if you haven't pre-prepped the data. Then next step is to explore it. Always is recommended to just explore the data, just take a look. What is it? What does it talk about? At least how is the distribution? And we're going to see this in a sec. And then once you satisfy or say, okay, I'm ready, you're going to start creating stories. Now, create story. Story is the insights in the UI with the charts and the explanations. But behind the scene, there is a model. The model gets created with its metrics. So every time you're creating a story, it's a model behind the scene. And you can create multiple stories, multiple models on the same data set. Like I said, maybe this is for stages 0 through 2, stages through 3 through 4, whatever, or this is for a MER, this is for a MIA. You can create multiple stories on the same data set. You filter it in the story. And once you're ready, after a couple of iterations or several iterations, you're good with the model accuracy. You deploy this under a prediction. So you create a prediction. If it is the same data set, multiple stories, you can still create them, deploy them under the same prediction. Once the prediction is created, then it can be consumed in a Lightning component that's on the, let's say, on the account page. Is it going to churn or not? 77%. These are the reasons. This is Salesforce embedding, or just you're putting prediction back in Salesforce. You can use it in an API call, any system out there. It talks to the Einstein prediction API, so it sends back the op stage, the amount, the type, and whatever these values. The API service reads these values, provides a score and the explanation and the action, and provides to that external system. You can rescore a data set in the recipe, so you can have a full data set, and you are using the prediction so you have an actual field, and now you create a predictive field or predictive field, and you have scored the data set. This can happen on a daily basis, for example, because you're scoring the live data. Or you can use in Tableau as of our latest releases. You can take that and put it in the dashboard layer there. And even there are a few functions, by the way. So there is a predict function. You can use it in the workflow, or even in Tableau there's a table calculation that you can use that prediction. And we will cover that in some other videos. So these are the terms that kind of wrap up the Einstein Discovery basic terms. and the different stages or categories where you will deal with them. So at the data set data prep layer, you have data storage, the data sets, you're going to deal with data prep. You're going to create some derived fields like those durations and flag. You might hear the word feature engineering. That's part of it here. You might hear hot encoding and pivoting data. So you don't need to really do hot encoding. ED does that for the data. That's auto taking care of it when you create the story and the model. But you might decide to do some pivoting beforehand, and any advanced calculations, that's in the data prep. Once you create the story, you get the model, you get all your input variables are the variables from the data set that you are saying, these are my variables, build the model on it. These are the historical information. So they could be dates, numbers, dimensions. Dimensions, you might hear the term categorical variables. Again, they pretty much it's a text, okay? It's a categorical. And you might hear also the word feature. So feature means, again, this is a simple term, but if you think about stage, or let's take an easy one. Let's take a region. Region is a dimension. I have a mare and I have a Mia. So a mare by itself is a feature. It's a value of a dimension. That's what it is. So if you hear that term, just think about it. It's the value of the dimension in my data set. So if you think about data set like this, right? I have region, I have a mare, I have a Mia, and then I have a maybe, I don't know, type, customer, partner. All of these here are features. Binning. So we bin the data. You can control that in the story. Binning, you mean, is like creating buckets for data prep or analytics folks. Grain of analysis, the grain of the data set, what's the lowest level, the unique record. Explains, we're going to talk about it, the power of any of these variables on the output. Output variable is the one we're trying to minimize, maximize, and explains this kind of the power. So maybe you tell me the region, I tell you if the opportunity amount is high or low. Outliers are data that's typically not there. So if you're talking about opportunities, again, most of my opportunities, let's say between 10K and maybe 1 million. And then I have 2 or 3 that are 20 million. These are outliers. These are not usual. Could be negative too. Strong indicator, that's like the churn reason. We talked about it. If a customer churns and we put a churn reason and we include this as an input, it's going to say, hey, strong indicator. Like, this is like a cheat way to tell you if the customer is going to churn or not. Collinearity, when 2 dimensions or 2 input variables, they look the same or they are affecting each other. They are might be duplicates. So I mean, an example, not super accurate, but you might have a city and I don't know, zip code maybe. If it happen, okay. Let's assume that if I had a neighborhood and a zip code, that would be very close, and they look like kind of the same. Data leakage, very similar. So again, and then we have some heavy stuff, statistics, model metrics, K, fault validation, coefficients, etc. Then when we're done with the story and model and go to predictions, this is where we create a prediction, which models are under this prediction, and we map the fields. So we map. So when we have somebody asking for that score, that prediction, they're going to provide the same fields that we have created, at least all of them. You can supply less, but you get less accurate information. Segmentation, if I've created multiple models, one for a mare, one for a Mia, prediction field on the object in Salesforce, terminal state of record of the record in Salesforce. Again, we'll cover this in deep in the deploy prediction video. And at the end, after you deploy, well, after that, you need to manage or monitor the model. So we have model manager in the product. You can monitor your predictions, look at the user statistics. There's an accuracy template, and you can even edit the model. So you have the full platform from the beginning till the end after operationalizing it and deploying it with all the tools. And these are pretty much what you need to know within the context of Einstein Discovery.